Hello everyone. Today in our session we will discuss production function, and we will largely first we will discuss about the general concepts of production function, and then we will try to connect them with the healthcare or healthcare operations. Now, the theory of production is basically a part of theory of the firm, theory of the firm. Now, firm is a production unit. Yeah. So, when a firm decides to produce something, it has also a cost implication. When we talk about our demand, our resource constraint and our efficient choices, we have to connect all of them together when we discuss about theory of the firm. Let us understand that we have, say we have a hospital system where we have limited number of doctors and plenty of patients. So, there is a limited supply, there is a constraint in terms of resources, in terms of doctors, nurses and other resources what we generally see in any public hospital in India, but the demand is enormous. Having said that, there is a cost implication, that the cost can be again monetary and non-monetary. The cost of the treatment as well as the other non-monetary costs, that there should not be any high prevalence of diseases or no mistreatment as far as that death can be avoided. So, the optimization is primarily is cost minimizing. The optimization in theory of firm is basically cost minimization process of production considering various input bundles. All right, this is our, these input bundles are our will determine that how my production will take place, or given the different input bundles what can be the optimum production. Now, having said that, this production in a firm can be obtained by production technology, number one. Number two, cost constraints, that is basically the budgets I have been given, that within this budget I have to produce whatever I want to produce. So, even if I have the supply of input, I cannot probably in a primary health center I cannot probably keep 5 doctors and 15 nurses. Yeah. So, I have a budget constraint for each primary health center, for each hospital, for each say public health awareness campaign, everything if we consider as individual production process, because everything has an outcome, everything has a production process, then there is a cost constraint, there is a budget constraint, that whatever I need to do, there has been stated already that this is your budget, within this you have to manage the entire operation. So, that is the cost constraint. So, even if I know my production technology, I can avail the technology, but having the technology I have been given that this is your technology, this is your cost constraint, and based on that I will decide my input choices. They are the production factors or factors of production, my input choices, that which will be the how many capital, how many labor, which kind of labor, which kind of capital, which kind of machinery, what will be the other ingredients in in a production process, whatever is required I have to decide based on the budget I have been given my production technology. Therefore, production function. Now, the theory of firm deals with both the theory of production and theory of cost. So, a production function can be stated as Q, that is the quantity of production, amount of production, as a function of K, which stands for capital, L which stands for labor. K basically is non-human capital and L is the human capital. Yeah. So L is labor, K is capital, but we must state given the technology. So technology is assumed to remain constant during a production process given the technology. So production or my output is a function of the capital and labor, the different combinations of number of capitals and number of labors, and the goods and services, the production of the goods and services will depend upon that. Why goods and services? Again, as I said, when I take the example of a hospital service, no, so it is not actually I am getting treated, it's not actually a good, it's the services I am availing. Wherever I am going to a shop or a pharmaceutical organization, manufacturer, they are manufacturing goods. So goods and services both can be treated as an outcome of a production process. When I float an awareness campaign program, say on HIV/AIDS, it's a service basically, and the outcome is the awareness among people about HIV/AIDS. Yeah. So and that awareness generation about HIV/AIDS depends upon how much capital I am putting in, as well as how many labor forces, who are those labor forces working towards this awareness generation program. So a production function depends upon time period, right? For how long I will be producing, or now given a time period I have certain constraints. Let us see what is time period. There are two types of time period or two types of production function given time period. One is short run decisions in terms of production. One is long run decisions. Yes. Now, what is short run? In short run, it's not, I cannot say that it's 1 day, it's 1 minute, it's 1 month, it's 1 hour or 1 year. There is nothing like that, that a short run should be a short period of time. No, there is nothing like that. A short run is a time period where I cannot adjust all the processes or all the factor inputs. I cannot vary all of them, which has a direct implication on cost. Yes. So in short run I have a limitation. So let us take a simplified example. When we have a 2-factor production unit that I have just 2-factor inputs, one capital, one labor maybe, and if in a short run I cannot change both these factors of production, I will change only one of them. I will only if it is possible. That's primarily, say suddenly there is a mishap in my locality where my hospital is there, and I have to treat up, there is an inflow of patients, say 50 patients suddenly come in. Now what do? I cannot get the number of doctors, suddenly I cannot increase the number of doctors. I cannot increase the number of nurses suddenly. Maybe what I can do is that I can ask for some volunteers. If I have a medical college in that hospital, I can ask some medical students to pitch in. I can take help of some blood banks or some other medical equipment supplying agency who can provide me at a very emergency notice that they can provide me certain basic minimum or basic necessary healthcare requisitions, yeah, healthcare or treatment commodities. Now, so that is the short run. It can be a 1 day, even a short run can be 1 year if it's a large production process, yeah. Whereas in long run, so in short run I can only change the cost or I can only vary the cost based on either very few in a multi-factor units, in a very few of these factors of production, or else I can just change the production process, that's all. Where in long run I have enough time in my hand so that all the factors of productions are variable. All the factors are variable. So I can change it according to my wish. I want to change in that particular hospital, I want to change next year maybe 50 new beds I want to introduce. I can do that. I can sanction a budget. I can kind of do a predictive modeling that what has been in the last year and what can happen in the next year, whether I am seeing an increase in demand, whether I can see the prevalence of certain ailments in that particular locality. I can open a new discipline, maybe orthopedics, maybe neurology, maybe oncology. So all these things I can do, and to make all these changes, the basic necessary time, the minimum necessary time I will require, that can be considered as the long run, and there onwards any time period can be our long run. So now, after stating my production function Q as a function of capital and labor, given technology, I don't have to mention this all the time, but we need to keep it in mind. Yeah, given technology. So Q stands for total output, K stands for total capital, L stands for total labor. Together that capital and labor is giving me an output of that amount of Q. Therefore, as we can go back to arithmetic mean or average, my average production, which we can say AP, average production or of labor, which can be stated as output per labor or per unit labor. Yes, APL can be stated as total number of output divided by total labor. So total product divided by total number of labor, which is required to manufacture that many output. Similarly, average productivity of capital can be total product divided by total number of capital. So total product divided by total number of labor required to manufacture that amount of product. Similarly, over here total product divided by total capital. This is the average product of labor and average product of capital. It can be the total number of patients being served or treated by one doctor in a particular district, in a particular state, in a particular primary health center. Yes, so total number of patients in a particular time period divided by total number of doctors. Yeah, that is the average product of the doctor. The next concept is marginal product of input. I can keep it as labor. Marginal product of labor. I can write it like MPL, marginal product of labor. Now, this marginal product, again, if we go back to our marginal utility concept, marginal is incremental. Yeah, how to remember it? When we talk about marginal utility, we talk about change in utility. Then we think why utility is changing, because of consumption of one extra unit of a particular commodity. Similarly, here marginal product of labor, again marginal is associated with which word? Product. So that is incremental change or the total change in the total product or total production, total output, by why output changes? Because of the inputs, either because of capital or because of labor. So total change in capital or total change in product by one unit change in either in labor or in capital. So we can state it like delta Q, marginal product of labor is delta Q by delta L, whereas marginal product of capital can be stated as delta Q by delta K. isn't it? So that is the, again I will repeat it, that marginal product, change in product of, when I say labor, that means change in product because of 1 unit extra labor. Similarly, marginal product of capital is change in total product because of 1 unit extra capital. So that is my marginal product of labor and marginal product of capital. So it says us, when we hire or recruit one extra input, be it labor or capital, what is its implication? How much is it returning towards my production, total product? Yes, and then I can have an idea that whether we will go on increasing more and more labor or capital, or we will stop at a particular point of time. Yes, because my budget has a limitation and I will have to make an efficient choice. I cannot take too many labors or too many capitals. We will learn it now. Say, let's take a very simple table. Yes, and then we'll go how this average product or marginal product behaves. The simple table here will take amount of labor. Let's take it as 0, 1, 2, 3, 4, 5, 6. Amount of capital. Amount of capital, will keep it fixed. It's a short run production function, and 2 input production function, 2 factor. Total product, which is basically our Q, is, this is our L, this is our K. Total product is, say, 0, 100, 250, 350, 400, 400, 380. Yes. So what we see, let us first calculate the average product, or APL, average product of labor, APL. I won't do average product of capital because nothing is changing essentially. Yeah? Everything is similar, but we still can calculate 0 by 10, 100 by 0, 250 by 10, but here capital doesn't really make sense. That's primarily because labor is a variable factor. When I try to compare with different scenarios with different number of labor, I will look at the labor, because that's where I am changing my decisions. And over here I will keep marginal product of labor. Yes. Now so average product over here is 0 because anything it doesn't really make sense, 0 by 0. The amount of labor over here is, average product is 10 by 1, 100 by 1, 100, right. Over here 250 by 2, 125, 350 by 3, it should be 116.7, 400 by 4, 100, and so on, 80, and it should be something like 63.7. Yeah, or 0.3. Yeah. So the marginal product, again here it really doesn't matter. So when I don't have any labor, I incorporate the first labor. So again, if you go back to the marginal utility class, here I will do delta Q by delta L. It's basically delta Q by delta L, and this delta Q by delta L is basically you know, 100 minus 0 by 1 minus 0, isn't it? Because I am incorporating one extra unit of labor and my total product changes from 0 to 100 when my labor increases from 0 to 1, keeping the number of capital same. Therefore, my marginal product of labor is 100. You can also do it 100 minus 0 if there is the changes is 1 unit, you know, every time. Over here it's 150, 100, 50, 0, minus 20. Yes, so 100, 150, 100, 50, 0 and minus 20. Let us see how it really matters, you know. So, going to the, if I plot them graphically, I can see that the total product, generally I am not plotting this particular graph, but at the, you know, it is universally same. So, when I plot a total product curve, over here you can see it increases, right, 0 to 100, 100 to 250, 250 to 350, 350 to 400, 400 it remains constant and then it comes down to 380. That means it is increasing. Initially it is increasing at a very fast rate, and then it, you know, when we look at the marginal productivity, we can see if it has increased by 100 units, 0 to 100, then 100 to 250, again at a faster rate, and then 250 to 350, the rate slows down, but it is increasing. 350 to 400, it is increasing, the rate is slower. 400, it doesn't increase anymore, and then 380. We have a proverb in probably all the languages. I will just take the English one. Too many cooks spoil the food. Yes. So, here we have seen that when we kept on increasing the number of labor, the production finally went down. So, we have to decide till which point we will continue our production process. Very nice. So, when we plot total product curve, when we plot a total product curve, over here output in a given total product in a given period of time, and over here you will mention your input, labor or capital, whatever. So, initially it increases at an increasing rate, So, dy dx is, you know, the first order derivative is positive, the second order derivative is also positive, d2y dx2. So, it is increasing at an increasing rate. Next, it continues increasing, but at a decreasing rate. You can see it is increasing at this phase, but at a decreasing rate. At a certain point, it is being stagnant, and then it comes down, right. That is what we saw here. It is increasing at an increasing rate, first 100, then 150, then it started falling down, 100, 50, increasing 0, and then it decreased to 400 to 380, right. If we take a very simple example, you know, say production of a bike. I have got a new bike. So, the mileage when I buy a new bike, it's not really high, you know. So, but it increases at an increasing rate. But after a certain year, with its depreciation, the mileage probably increases, but then it increases at a decreasing rate. And then after a certain while, when it's old, the mileage starts falling. Yeah. So, it can be visible in all production process almost, yeah, across the world. Now, therefore, this is my production process where you can see by the slopes are steeper and it starts getting flatter. At this point, it's stagnant and then it's decreasing. Yes. So, it's decreasing here. Anyways, now if we want to plot the average product curve, how does it look like? An average product curve, if you see here, it again increases 100 to 125 and then it falls, right? 125 to 116.7, 180, 63.3. But even if the marginal product goes to negative, average product does not go to negative, because it won't, because the total product is never negative. Yeah, marginal product can be negative because it is showing the change. Change can be negative, but the total product together, even if it is falling down, it can maximum be 0 if they start stop operating, but it cannot be negative, right? So a total product is an absolute number, so it cannot be negative. It's a non-negative form. Now, therefore, average product will never go to a negative point. And hence, as we observe here, it is increasing and it's then decreasing. You can keep your average product curve something like inversely U-shaped curve, average product, and inversely U-shaped curve. Yeah, you can write here as APL, right? Over here is it's L, over here it's Q, right? Now, if we put, this is labor yeah, L. If we now plot marginal product, what we see in marginal product again, it increases. See, both of them are at 100 and then average product is at 125 and it goes high 150 and it falls very fast, So the marginal product at the very initial stage will grow faster than the average product, will grow faster. So it can start from the same point, but it grows faster than the average product and then it comes down maybe till the negative point where it is like 400 to 380, that minus 20, it goes down to minus 20. So if my average product is inversely sloping, my marginal product is also inversely sloping, but the slope is steeper for this marginal product curve. If I want to keep them together side by side and try to analyze what happens, I can observe few things. Number one, when marginal product equals 0, when marginal product equals 0, TP, total product, is at its maximum. Yes, at this point marginal product, if I plot it here, maybe if I plot it here, maybe it's something like this at this point. At this point, my marginal product goes to 0 and the total product is at its maximum. Number 2, when my marginal product is greater than average product, when at this point, when my marginal product, you can see at this area, when my marginal product is greater than the average product is increasing. Average product is increasing. When my marginal product is greater than the average product is increasing. So I will say average product is increasing. Third, when my marginal product is less than the average product, when my marginal product is less than the average product, my average product is decreasing. At this point, right? My marginal product is less than the average product and we can see my average product is decreasing. Anyways, and when marginal product equals average product, when marginal product equals average product, my average product is at its maximum. So you can keep it like this, something like this. At this point your average product is maximum. Yes, at this point when marginal product is equals to your average product. Okay. Having said that, now we will discuss something about law of diminishing marginal returns. Law of diminishing marginal returns. Now, when I talk about marginal, again it is incremental, right? So, it can say that as the use of an input increases in equal interval or equal amount, a point will be reached after which the resulting additions to the output will decline. That means, if I go back, here we can see in this, we can see there is a point at which my average product or my total product has increased, after which it has started declining, right. So, basically the MP, when it starts falling, then we will see, because why we say MP, why not total product? Because we are saying that when my input increases by one additional unit, the additional contribution to the total product, that is my marginal product, starts declining. Yeah, so that is diminishing marginal return. Now, return, we say that what is your return? How much is the return? That means how much output, how much outcome you are gaining from something. What is the return you are gaining? Marginal return is similarly marginal output or marginal product. Now, diminishing marginal returns means diminishing marginal product. So, naturally here when we talk about diminishing marginal return, we do not talk about the point where the average product or the total product is decreasing. We are basically talking about the point where the marginal product is decreasing. So, when MP declines or decreases after reaching a certain point in the production process, yes. So, generally when the labor input is small, when I have lesser number of labor at the initial phase of, now it can be labor, it can be capital again. Why we are talking about labor? Because we have taken the example of labor, we are continuing with that. So, when the labor input is small, the marginal product increases because of the labor specialization. When there are only few labors, so I have chosen those few labors based on their specialization, that I know that they are specialized in these areas. So, even if I have a small amount of labor, they are so specialized that they can, they can run the show on their own, right. So, when the labor input is small, marginal product increases due to the labor specialization. I will note it down. When labor input is small, MP increases because of labor specialization. Yes, The second point is when the labor input is large, MP decreases due to inefficiency. When labor input is large, MP, marginal product, decreases due to inefficiencies. Too many cook spoil the food. Too many cooks spoil the food. So, you know, if I have too many laborers, you know, then, and we have seen, you know, in several public sector units, we have seen that there are too many laborers than it was required, and what happens is they just don't produce at the efficient level, and the cost of that production process is so high that after sometimes they run out of the business, they cannot continue, right? So we need to decide, we need to remember that what is the number of, you know, labor. Yeah, we need to keep to continue the production process. The law of diminishing return can also be used, diminishing marginal returns, not diminishing return, better to say diminishing marginal return, so that we remember that it's actually the marginal products is declining. We can also decide that what should be the trade-off between different, you know, configuration or different bundles of labors on capitals or different inputs. You know, what can be the trade-off, that how many capital and how many labor in the long run, where I can change both the capital and labor, right? In the short run I cannot, but in the long run I will certainly be able to change. So this law of diminishing return, if I can point it out as a third point, it helps us, you know, apart from those two, that when my labor input is small, I have to keep in mind that I have to get specialized labor. When the labor input is large, I have to keep in mind that there is no inefficiency. At the same time, at the third point, it helps us to identify the trade-off between different plant configurations. Yeah, and it eventually assumes that the quality of the variable input is constant. When I continue changing the number of inputs or increasing the number of input, I am actually getting the same quality input. You know, so it's not varying. So when I am increasing labor, more and more labor, the quality remains same. Yeah, there is no variation that the next labor is, you know, extremely capable, or he is tremendously incapable. No, it's nothing like that. Yeah, so the quality of the variable input remains constant or same. Yeah, the fifth point can be, it explains a declining marginal product, not necessarily a negative one. If you know that, you know, the number of production is not going to go down, it's not marginal product is negative. So when we go back to our this slide, this entire area is determining or discussing or talking about the decreasing or diminishing marginal returns. Not necessarily it is eventually this, but not necessarily this part. Yes, it can be this part where it is just declining, even if it's not going to be negative. So not necessarily the negative part of marginal product curve or marginal product schedule. Number 6 is it assumes a constant technology, right? That's the assumption we took when we started discussing about production function, that it assumes a constant technology. whenever we change any factor of production, the technology never changes, so it remains constant. But if we consider that there is a technological improvement, what happens? What happens to the total product curve? If there is a change in the total product curve and due to pertaining the technology, over here this is my total output, total product, and in the x-axis I mentioned my labor input in a given period of time. And if my production process is something like this, smoother, yeah. So with the production process, improvement in production process, it gets shifted in a pivoted manner. And we can see that with the same amount of labor, they are almost reaching the highest point at the same period of time or with the same amount of labor. But the total product curve has shifted upwards from 1 to 2, from 2 to 3, which shows the amount of production with the same amount of labor, even if they have reached the maximum total product, after which the total product goes down. With the same amount of labor they have with all three different technology, they have with those many labors, they have achieved the maximum. After that it's same. After that they go down. But what is different is the amount of production which is being produced. So when technology changes, there is a pivotal upward shift of this total product curve, pivotal, because all of this starts from the origin, no input, no output, right? This starts with the origin mostly, mostly, and then at least we can assume here that it's happening like that, and then it goes through a pivotal shift. Yes, when we talk about long run curve, as we said, in a two factors of production, when we consider two factors of production, both the factors are variable. So here we are talking about long run production function, where number 1, both the factors of productions are variable, where both the factors of production in a two factor production, both the factors of productions are variable. Yes, and we understand this scenario based on a isoquant, where iso means same, quant means quantity. Yes, isoquant. Iso means same and quant means quantity. But what is this same quantity? We achieve a same quantity of output given different combinations of capital and labor. So I go back to my indifference curve, where the satisfaction was same with different combinations of two commodities X and Y, apples and oranges, rasgulla and gulab jamun, and so on and so forth. Yeah, paracetamol and two different paracetamols, doctors and nurses, paracetamol and antacid, whatever, any two commodities, and my satisfaction remains same. Here, and different combinations of those commodities where my satisfaction is same on the same curve, which is indifference curve. Here it is altogether same, isoquant. In the same curve, I get different combinations of capital and labor, which gives my IQ stands for isoquant, as IC for indifference curve, and I get different combinations of capital and labor, which eventually, let us take that it is 100 units of, or let us say 100 patients. 100 patients, and over here we can take as doctors and nurses or something like that. Doctors and some other capitals, maybe capital, it can be bed and other equipment. Yeah, and then we can have different combinations of doctors and capitals, or healthcare providers, it can be doctor, nurse, anything, and capital. Yes, in a primary health center there should be at least one doctor, 3 nurses and 1 male nurse. Yes, total 5. We hardly have, in any PH we hardly have filled up that quota. Anyways, so this is the isoquant which gives, and now you can see as it's a long run production function, we can see that both the capital are varying and then the labor can also vary. And while I am varying the capital and labor, we are identifying all different combinations which give me a desired level of outcome. So, if I want to increase, again more is better, I want to increase my production, I can either increase capital, I can increase my capital keeping the labor same, or I can increase my number of labor, I can increase the number of labor keeping the capital same, or if I want to go to this point, I can increase my number of capital keeping the labor same. Yes, so and it varies, and then I can change both the capital and labor to remain on a higher indifference, higher isoquant. That's upon you completely. So, when in isoquant we have like the diminishing marginal return. So, what happens if we plot this diminishing marginal return on isoquant, what we see, we can observe something like this. Again, as in difference curve, 2 isoquants cannot intersect each other, they will only shift parallelly. So, if this Q, or I can write it as IQ1 is 55, IQ2 is 75 and IQ3 as 90. Okay. Now, what I observe is my labor is 1, labor is 2 and labor is 3. Labor is 3. Now, with this 3 labor, when I increase my number of labor from 0, 1, 2, 3, I observe that my the output is increasing by first 20 units and then 15 units. That means the marginal return with every single unit of labor is decreasing, right. So, diminishing marginal return is being followed when it increases from 0 to 1, it is by 20 or say I will keep it like say 1 to 2, it is by 20 units, from 2 to 3 it is 15 units, or from 0 to 1 if you want to keep, then it is by 55 units. Yes, that is the diminishing marginal return, and the same can be observed in terms of capital. If my labor remains fixed at 3 and my capital increases from 1, 2 to 3, and I can see from 0 to 1 for capital, 0 to 1 it increases by 55 units, from 1 to 2 it increases by 20 units, 75 minus 55, and from 2 to 3 it increases by 15 units. So diminishing marginal return is being followed here. Now, when we talk about the slope, if you can remember the indifference curve, the slope is given by the substitutability, marginal rate of substitution, right? The substitutability between two commodities. Yes. Now, here in a similar way, when we talk about the slope of isoquant, we talk about the trade-off between two inputs. Now, that can be stated as marginal rate of technical substitution. Marginal rate of technical substitution. What is different here? The difference is the word technical. The difference is the word technical because it's a production process. Marginal rate. So whenever it's marginal rate of substitution, we are talking about the consumer behavior, substitution between two commodities. Whenever it is marginal rate of technical substitution, we are talking about technology, we are talking about some production process, then it's like marginal rate of substitution between, whenever it's a technical substitution between two factor of production, like marginal rate of technical substitution, which we can state like MRTS is given, the minus you can give, you cannot give, it's upon you, is the change in capital with respect to 1 unit change in labor. It can be the other way around as well, delta L by delta K. So change in one factors of production with respect to change in the other factors of production at fixed level of Q or fixed level of output, right? Because on an isoquant output is same, and when I am at the isoquant, I am trying to see the rate of trade-off substitutability between capital and labor. Yes, and that is given by this delta K and delta L on a particular isoquant where this output is fixed. Yes, therefore, when we are talking about the slope or margin of isoquant or marginal rate of technical substitution, it gives us an idea that for one additional unit of capital, how many labor I will sacrifice, or vice versa. For one additional unit of labor, how many capital I need to sacrifice to remain or to produce a particular amount of output. Yes. So this is the implication, or this is the interpretation of the slope, that with per unit capital or per unit increase in labor, how much capital I am sacrificing. Therefore, in marginal rate of technical substitution gives you an idea about that for say 1 and we can see for 1 unit of labor with while increasing labor, when it is increasing by 1 unit, 1 to 2, 2 to 3, 3 to 4, 4 to 5, 5 to 6 or 0 to 1, how many capital I am sacrificing? Say this is 70, this comes down to 55, this comes down. So here I have sacrificed 15 units, this may be my 45. This can be, so here 15 units, 10 units, this can be 40, this can be 36 or 37 and so on. So the amount of capital I am sacrificing, it's coming down. That's primarily because that technical, and this is called the diminishing rate, you know. So what is happening when I am sacrificing, when I am at the lower level of labor input, I will require more and more of capital. When my labor input increases, I don't want to, my capital input is coming down, and at a certain level I don't really want to sacrifice that many capital, because capital also is also useful and very useful. So I will have to keep a basic minimum level of capital, and with the further increase of labor, this labor input is turning inefficient, which inefficiency has to be made up by the capital, the minimum level of capital, because over here if I am causing inefficiency with more and more labor, I cannot afford to lose more and more amount of capital. So that I am being I am being kind of skeptical in terms of sacrificing the amount of capital, so when I am increasing my labor. So this is the diminishing or decreasing marginal rate of technical substitution. Thank you.